Europa, one of Jupiter's moons, is an icy world that has captivated scientists for decades, largely due to its potential to harbor life. Beneath its thick, frozen surface lies a vast, salty ocean that is believed to be in contact with the moon's rocky mantle, creating an environment that might support life as we know it, or even life as we don't. Europa is a small moon, about the size of Earth's moon, and its surface is coated in a thick layer of ice, several kilometers deep. But beneath this frozen crust, scientists speculate there is a liquid ocean kept warm by tidal forces from Jupiter's immense gravity. These tidal forces stretch and squeeze Europa's interior, generating heat through a process called tidal flexing. This warmth could allow liquid water to exist beneath the ice, despite the frigid temperatures on the surface, which can dip to minus 160 degrees Celsius or minus 260 degrees Fahrenheit. The ocean itself is thought to be in contact with Europa's rocky mantle, which is crucial for the possibility of life. On Earth, deep sea ecosystems thrive around hydrothermal vents, where heated mineral-rich water interacts with the ocean. Europa's subsurface ocean could similarly host such vents, where chemistry could mimic the processes that led to life on our own planet. Life, like as we know it, relies on certain chemical elements and compounds, water, carbon, nitrogen, and others, to form the complex molecules that make up living organisms. Europa's ocean, though not directly observable yet, likely contains many of these building blocks. In 1999, NASA's Galileo spacecraft detected traces of sulfuric acid on Europa's surface, suggesting that chemical reactions might be happening between the moon's ocean and its icy surface. These reactions could produce organic molecules, which are the foundational ingredients for life: water, carbon dioxide, methane, and ammonia, key elements for life, have been detected in Europa's thin atmosphere, adding to the potential for life-supporting chemistry beneath the ice. The deep-sea vents on Earth, where life thrives without sunlight, rely on chemical reactions, such as those involving hydrogen sulfide or methane, to produce energy. Similarly, Europa's hypothetical hydrothermal vents could generate heat and energy-rich compounds, creating the conditions for life to arise in its ocean. Life on Europa, if it exists, would likely be very different from life on Earth. The absence of sunlight on the ocean floor would make photosynthesis impossible. Instead, life would likely rely on chemosynthesis, a process in which organisms derive energy from chemicals in their environment rather than from sunlight. On Earth, microbes around hydrothermal vents use the chemical energy from minerals in the Earth's crust, such as hydrogen and methane, to produce organic molecules and sustain ecosystems. On Europa, similar processes could take place around hydrothermal vents located on the ocean floor, where the ocean meets the rocky mantle. These vents might spew out water rich in minerals and chemicals, such as hydrogen and methane, which could provide the necessary energy for microbes to form and sustain themselves. Another potential source of energy could come from the radiation that Europa receives from Jupiter. Though dangerous to surface life, Europa's icy shell could act as a shield, protecting life in the subsurface from harmful radiation. It is possible that microbes in Europa's ocean might use the chemical energy produced by this radiation through processes like radiolysis, where radiation breaks down water molecules into hydrogen and oxygen to survive, just as life on Earth has adapted to extreme environments. The biggest challenges for life on Europa would be the harsh conditions. The ice shell is extremely thick, and any organisms living beneath it would have to survive without direct sunlight. While the ocean may be kept warm by tidal flexing, it is still likely to be extremely cold compared to Earth's oceans, and the water itself may be under high pressure. Furthermore, the radiation from Jupiter is intense, and any life forms would need to be shielded from this harmful radiation. However, the possibility of life on Europa doesn't hinge on the conditions being identical to those on Earth. Life on Europa could take forms that are unimaginable to us. Microbes that rely on chemosynthesis instead of photosynthesis, or organisms that can withstand the extreme cold and pressure. The ingredients for life, as we know it, may be present, and the environment could provide the right conditions for life to form and thrive. In recent years, the James Webb Space Telescope and the upcoming Europa Clipper mission are providing new tools to investigate Europa. The Europa Clipper spacecraft, set to launch in the 2020s, will fly by Europa multiple times, analyzing its surface, ice, and potential plumes of water vapor that might be venting from the subsurface ocean. These plumes could provide a way to sample the moon's ocean without drilling through the ice. Scientists hope to answer fundamental questions. Does Europa's ocean contain the necessary chemical ingredients for life? Are there signs of active biology, even in microbial forms? What can we learn about the processes of life that could help us understand the origin of life here on Earth, and whether it might exist elsewhere in the universe? Europa may be a barren, frozen world on the outside, but beneath its ice, it could harbor a hidden ecosystem that could challenge our very understanding of life. Whether life ever arose there or could still exist is one of the most profound scientific questions we face. The story of life on Europa, if it exists, is still being written, and it could offer clues to the origins of life throughout the cosmos. Please remember to like and subscribe, and feel free to leave any content suggestions in the comments section.